under ray optics, we come across one more phenomenon known as refraction of light. When the light passes from one medium into another, there are two possibilities. One is reflection and the other is refraction. Reflection is bouncing back of light to the same medium. That is, light bounces back to the same medium after incidence at the interface between the two medium. That is known as reflection. You have made a study about it in the previous class. Let us understand the refraction of light in detail. And one more possibility is the ray of light passes through another medium with bending of light ray. The reflection becomes a major when the interface is opaque. If the interface is transparent, refraction becomes the major. Most of the rays pass through with bending of light in the other medium. This bending of light ray, it is known as refraction of light. There are two mediums to understand refraction of light in detail. We need to understand the meaning of the medium. There are two media, denser medium and rarer medium. What is the meaning of denser and rarer? Meaning of denser medium. It is not related to the mass density, mass by volume. It is not that case. It is nowhere related to mass density of the material. It is the optical density of the medium. Optical density of the medium. What is meant by optical density? When the ray of light passing through the medium, the molecules of the medium are of course in the nano size. These molecules are getting interacted with the light radiation while it is passing through. Due to this interaction, the molecules absorb light radiations and re-emit them. Absorption and re-emission. Absorption of light radiation and re-emission of light radiation. It is known as optical activity of the molecules. Due to this interaction, there is a delay in light passing through the medium. In other words, the velocity of the light in the medium is decreased by a little. There is a decrease in velocity of the light. It is known as optical activity. Where there is, it is also called as absorbance of the medium. It is known as optical density of the medium. It is also called as refractive index of the medium. Refractive index of the medium or absorbance of the medium. Where there is more absorbance, more absorption of light, more emission of light. More refractive index. Where there is a more absorption of light, there we see more reduction or more is the velocity of the light which decreases. More decreasing velocity of light. That is why interrelated. It is called as optical density. Among this denser medium and rarer medium, the denser medium has more optical density, more absorbance, more refractive index, and rarer medium, it is less optical density, less absorbance, and less refractive index. That is the one we need to understand. Meaning of rarer medium, meaning of denser medium. In denser medium, light velocity decreases more. In rarer medium, light velocity decreases less. That is why we observe the possibility of bending of light. The bending of light ray, it is due to variation of velocity in the medium. There are two possibilities which you can understand with this geometrical representation. What is this geometrical representation? The straight line, this straight line, and this straight line. This straight line is a ray of incident light. This straight line is a ray of refracted light, and this dotted line is normal to the point at the interface. What is meant by the normal? That is a line drawn perpendicular to the interface at the point of incidence. This is the point of incidence. It is called as normal. Where you can see bending of light towards the normal and bending of light away from the normal. Look at that. Light supposed to passes in straight line like this if there is no median difference. So it is because of the bending towards the normal, here bending away from the normal, is bending away, supposed to be this away. There are two possibilities. It happens when the light passes from a rarer medium to denser medium, light bending towards the normal. This happens when the light passes from denser to rarer medium, bending away from the normal. This angle between the incident ray line and this line, normal and incident ray, is called angle of incidence. And the angle between this line and this line, normal and the refracted ray, is angle of refraction. Here, angle of incidence, angle of refraction will not be same. It is less, this is the case. It is more than I, this is the case. That is what? Observable. These are observable with the light passing from one medium to another medium. It is all because of a difference in optical density. More denser, less denser. Based on these observations, two laws were formulated by the scientist known as Snell. They are known as laws of refraction. Two laws. The first law, so in this geometrical diagram, the laws are formulated. First law is there are three straight lines, that is a line and line and line, and all these straight lines, that is incident ray, refracted ray and normal, at this point of incidence, at this interface, all of them are in the same plane. They are in the same plane. All the lines are in the same plane. They are this refraction or this refraction. All the lines should be in the same plane. That is known as first law of refraction. And the second law, it is also called as Snell's law. What is second law? Second law says when the angle of incidence varies, angle of refraction also varies in proportion, but in proportion. If angle of incidence increases, angle of refraction also increases. If angle of incidence decreases, angle of refraction also decreases, but in proportion, so that the ratio remains constant. What is the ratio? Ratio is, that is sine function of the angle. Not direct ratio, not I by r. It is sine I divided by sine r. Sine function of the angle of incidence, sine function of the angle of refraction. This is a trigonometric function. The ratio of these two is always constant. This ratio is constant, even though I varies. If I varies, r also varies, but ratio remains constant. This ratio is called as refractive index of the medium. It is n to 1. This is known as refractive index of the medium 2 with respect to 1. So here refractive in this medium 2, medium 1. Refractive index of the medium 2 with respect to medium 1. Here refractive index of medium 2 with respect to 1. So this is a constant value, what I said. It is related to the absorbance or optical density refractive index. So it is relative measurement, relative refractive index of the medium 2 with respect to 1 when it is passing from one medium to other medium. This is a constant value. This is defined also in terms of refractive indices, that is absolute values. This has its own refractive index, this has its own refractive index. This refractive index is N2, refractive index of the medium 2, refractive index of the medium 1. That is N2 1 is equal to like this. Suppose N1 2 is equal to N1 by N2. What is this N2 by N1? These are absolute values of the refractive indices. Absolute values. What is meant by absolute values of the refractive indices? The absolute value of the refractive index, it is with reference to the vacuum. Refractive index of any medium is absolute value. It is taken as a reference with reference to a vacuum, because in vacuum light velocity is always maximum, that is the highest velocity. Maximum is 3 into 10 to the power of 8. 3 into 10 to the power of 8 refractive index of the medium. And in the other medium, the light velocity decreases. Here it may be 2.8 or 2.9, 2.7 or 2.75 like this. If you take this value, it is more than 1 point something like this. If I do so. So this is always a constant. Velocity of light in vacuum is a constant, 3 into 10 to the power of 8 meter per second. In other medium, light decreases because of what is that optical activity. The ratio is called as velocity ratio. This velocity ratio is called as absolute refractive index of the medium. So this is one medium with reference to vacuum. This is another medium with reference to vacuum. Values are variable. Higher value or lower depends on the optical activity. So denser means optically more denser, rarer means optically less denser. These are relative values, and that is Snell's law. It is given by this formula as well. And I said the refractive index, it is all because of the variation of velocity. It is always a ratio of velocity. If we take vacuum and other medium, it becomes absolute values. Here, two different mediums, it is not vacuum. We take this refractive indices as a velocity ratio. Velocity of light in the medium 1, velocity of the light in the medium 2. That is ratio. So, this value n21 is equal to, either you can write this formula or this in terms of velocities. And also in terms of other formula, other concept, lambda concept. What is lambda? Wavelength of light. Light is an electromagnetic radiation, as you know. Electromagnetic is one wave. So length of one wave is called as wavelength. Here, when the light passing from one medium to other medium, the frequency of the light remains same because it is emitting from the same source. The frequency of the light remains same. Here, frequency of any radiation, electromagnetic radiation, this light is electromagnetic radiation. You can define the frequency of light by C by lambda. What is C? Velocity of that radiation in vacuum. That is always this value. Lambda is wavelength of the radiation. I said, while the light is passing from one medium to another medium, frequency remains same, but velocity changes. As the velocity changes, wavelength also changes, so that the ratio remains constant because frequency should remain constant. That means, if there is a decrease in velocity of light, there should be a decrease in wavelength of light, so that ratio remains constant. If there is an increase in velocity of light, there should be increase in wavelength of light, so that ratio remains constant. That is why velocity and wavelength are directly proportional. Here, velocity of light in the medium 1, it is wavelength of the light in the medium 1. Velocity of light in the medium 2, wavelength of the light in the medium 2. So we have many equations or many formulae. That is Snell's law. It is also written like this. It is also written like this: refractive index of the medium 2 with respect to medium 1, V1 by V2. Here N2 by N1 or lambda 1 by lambda 2. Lambda 2. These are the equations, very important. Using this equation, we can work out many problems given according to the data given. That is laws of refraction. That is about the details of refraction of light. In physics, we talk more about refractive index medium, and we have different field of study. That is different field. It is physics, fundamental physics, and we have different field in which the same concept is studied. That is in chemistry and biochemistry. The field is vast. In this field, refractive index, it is given by optical density or absorbance. What I said. The same concept, different terms, optical density. Here, in chemistry and biochemistry, the medium is, that is solution. What is solution? Maybe liquid solution or solid solution or gaseous solution, doesn't matter. The solution is a homogeneous combination of solvent and solute. Solvent may be water. Solute may be any substance, any chemical substance, any biological substance. There are numerous chemical substances, biological substances, which are optically active. Solid molecules are not optically active, but solute molecules are optically active. Which are optically active means these molecules occurs in nano size. These molecules can absorb light radiation and emit light radiations. As a result, what is that? There is a decrease in velocity, bending of light like this. So this bending or absorbance, what is that? Absorbance is measurable, or optical density or OD is measurable. It is comes under Beer's Lambert's law in that concept. Absorbance. Absorbance means where there is more light activity, that is molecules which are light active molecules. Light active molecules are solute molecules. So this absorbance of light, or I say refractive index or optical density of the solution, is depends on the concentration of the solution. Concentration means more solute in the same volume, more amount of solute molecules. Higher the concentration, higher is the OD, optical density, direct relationship. OD is measurable directly using instrument. So we can have different concentration of solution, we can measure optical density. So similarly, what is that? With a solution of unknown concentration, that concentration not known, we can measure the OD on comparing that concentration and OD from the graph, Beer-Lambert's law. We can able to write what is the concentration. We can determine the concentration of the unknown solution, unknown concentration. Concentration determined, or solution concentration which is not known. This is a vast area in chemistry and biochemistry, is a quantitative analysis. So analysis of chemicals and analysis of biochemicals, specimens of biochemicals, quantitatively you can measure using this concept. And the concept is measurement of optical density. Same concept, but you see in a different angle. That is one case. And one more field in microbiology. The same concept can be applied. In microbiology, we can study the growth of bacterial, microbial, that is microbes, and the growth of the cells, specific cells. The growth of microbes, maybe bacteria and other, and the growth of cells we can study using this concept. What is the concept here? The medium is again a solvent, maybe liquid or a gel like the phase, in which bacterial cells, but all bacteria are single cell. Bacteria is a cell. The bacteria or biological cell, which are what is the distributed universe. It is a solution difference area, nano size, and these are in micro size difference. These are bigger in size, particle size, micrometer, nanometer. So bacteria and biologicals are bigger, and this solution look like a turbid or cloudiness. And this we prepare using biological culture medium. What is biological culture medium? It is a medium in which the given bacteria is multiplied, or we can allow to grow in large number, multiply in large. The same bacteria, if you take two bacteria, multiply in multiple is millions and billions. Example, biological cell. Few cells into the medium, we can multiply with time. That is colony, biological cells will grow. And these are bacterial cells or cells. With time they grow or multiply and form what is that, a solution like this. And these are what is that, micro size. and the particles are bigger, but these particles actually will not absorb light, they scatter the light radiations. There is a difference. Absorption and re-emission only in case of molecules nano size, and here scattering of light by the part because they are bigger in size. So those can scatter the light. The scattering of light radiations also reduces the velocity of light. Optical density. The solution becomes more optical denser if the concentration of the bacteria or cells are more. That is, bacterial cell growth or concentration is directly proportional to optical density. Concept remains same, but the phenomena is absorption and emission of light, here scattering of light. Both of them will reduce the velocity of light. We can measure that as optical density using instrument. With time, we can monitor the growth of bacteria or growth of cell, specific cell. Time. As the concentration increases, OD increases. By measuring the OD, we can understand or estimate what is the growth of bacteria in that culture media. What is culture media? Is the media in which all the essential nutrients required for the growth of bacteria or cell are supplied. It is called as biological culture medium. Medium in which what is cell or gel is taken, in which you put all the essentials and the specific bacteria which is to be studied, small amount or cell to be put into that, and see with time how it goes faster or slower with time related with OD. So that is the bacterial growth or cellular growth. You can, that is, as light is impeded, this speed is reduced by absorption of light by the molecules. In this case, it is by scattering of light by the cells. In this case, that is the one. So this study, microbiology, is an important tool in medical diagnosis. See that medical diagnostic lab, we have this kind of any kind of bacterial growth or any kind of cell, we can magnify it and study data after this. So this field is different, vast field. Concept remains same. This is a vast field. Quantitative measurement, all this based on the Beer-Lambert's law. Concept remains same, but the field is different name. It is fundamental physics, refractory index. So with this, let us wind up this and continue with this in detail in the next class. Thank you very much.